So in today's video I will be discussing about some of the important formulas which will be used in the moment area method. Okay, moment area method. So suppose it's a cantilever beam and one load is acting at the end. So the bending moment diagram for this cantilever beam will be like this, right? So suppose this is a bending moment diagram of this cantilever beam. Now suppose we have to find the area of this beam. So we know the formula, area is equal to half into, this is the height and this is the base, h into b. So this is the formula for this type of bending moment. And suppose here at the center, this is the cg is nothing but center of gravity. So here what happened, from this cg to this h distance, suppose we have to find the L of this center of gravity to the end of h end. So here how to find this length? This length can be determined by 2/3 of the L. Okay, and from this perpendicular line to the center of gravity distance can be determined from this formula, that is 1/3 of the L. So these things are very important to remember. Okay, now again suppose it's a cantilever beam. Here in this case a point load was acting. Now here UDL load is acting. Okay, so in this case the bending moment diagram will be like this. It will be a parabolic. So in this case we have to find the area of this bending moment diagram. So the formula for this type of beam is 1/3 of h into L. This is the length and this is the height, right? Here we can also say that it can be b or length, it can be L. Okay, now this is the formula for finding the area of this type of beam. Again here suppose this is the center and this is the cg is nothing but the center of gravity. So from here to here distance it will be 3/4 of the L, and from here to here the formula will be 1/4 of the L to find this distance from the perpendicular to the CG and from CG to the H. To determine the L value is 3/4 of the L. Okay, now again I'll take another example, that is suppose it's a beam and here in the entire beam, one for a simply supported beam, suppose here in the entire beam UDL load is acting. So the bending moment diagram will be like this, right? So for this we have to find this is the H value. So for this type of beam we have to find the area, that means the formula will be 2/3 of H into L. This is nothing but the L. And to find the center of gravity, CG is acting at the center of gravity. From here to here distance, how will find the L value? That is nothing but L/2, half of the 2, and from here to this distance also it's L/2, half of the 2. So this three formulas, that is for a cantilever beam where point load is acting. Here in the cantilever beam UDL load is acting, and for a simply supported beam UDL load is acting. So these formulas are very much important for finding the slope and deflection in case of the moment area method. And in my next video we'll start with the problem for determining the slope and deflection by using moment area method. Okay, moment area method. Thank you.